Hello everyone, welcome back to chemistry class. In the previous lecture, we have studied about atomic number and mass number. So what is atomic number? Atomic number is number of proton present in atom of that element. And mass number, it is sum of neutrons and proton present in atom of that element. We have discussed about notation of atom, how to write notation of an atom. So you have chemical symbol, in the superscript you have mass number, in the subscript you have atomic number. And it is possible that mass number, number of neutrons may be different from number of protons. If atom is electrically neutral, then number of protons is equal to number of electrons. Okay. And we have seen cases of oxygen and aluminium. And in this lecture, we will study about isotopes. What are isotopes? Now, atomic number, as we have discussed earlier, atomic number of elements of the same element. Like if I talk about, let's say, iron. So, any atom of iron, it will contain same number of atoms, right? Same number of electrons and protons in it. But there are certain atoms of same element where atomic number may be same, but they have different mass number. Okay. Let's see this with an example. We'll take example of hydrogen. So when I am saying they have same atomic number, an atomic number is represented by subscript. The subscript here, atomic number is same of hydrogen. Symbol of hydrogen is H. But it is possible that the same hydrogen, it has different mass number. Now because as I told you earlier, most of the properties are defined by number of electron present in any atom. So here the symbol they have taken is same, this atomic number is same, but mass numbers are different. So these three are known as isotopes of hydrogen atom. Now here this one is known as protium. 2 mass number, that means in this you have only 1 proton and 1 electron. No neutron in this protium. The second one, 2. That means you have 1 proton, 1 neutron and 1 electron. This isotope is known as deuterium. Symbol is D. This one, 3. That means you have 1 proton, 1 neutron and 2 neutrons. 1 proton, 1 electron, 2 neutrons. This is known as tritium, symbol is T. Now in nature, 99.98% of hydrogen exists in this form, that is in protium form. That is 1 electron and 1 proton. Only the remaining exists in the form of deuterium and tritium. Deuterium is also known as, like if this protium, when it combines with water, when it combines with oxygen, it gives you water. That is H2O. That is your water that we consume, we use. When this deuterium, it combines with oxygen, it gives you heavy water, D2O. And that is used as a coolant in nuclear reactors. Here tritium, this one is radioactive. And abundant one is this one. 99.98% of hydrogen in nature exists in this form. Let's move to second example of oxygen. Isotopes of oxygen. So isotopes means you have same atomic number, different mass number. So here I have written 3 main isotopes of oxygen. This one, 16, that means 8 protons, 8 neutrons. 17, 8 protons and 9 neutrons. Here 18, that means 8 protons, 10 neutrons. Now in nature, this one is the abundant one. 99.7% exists in this form. That's what we breathe, generally react with things is this one. Second one is only 0.03% and last one is only 0.25%. Okay. But there are certain isotopes of elements which exist, like let's say example of chlorine, they exist in good ratio. Like this chlorine, it exists in 2 isotopes in the ratio of 3:1. That you cannot ignore. So in this case, mass number is find by doing average of these two mass number of these two isotopes. Now here if you see chlorine, the two isotopes of chlorine is 3517 and 3717. Now how to find mass number here of this chlorine? So what you will do is, you will take average of these two. Now why such thing? Because whenever you pick any, let's say if you are taking a piece of chlorine, in that you will find both of these isotopes in the ratio 3:1. So in that case, you have to take average mass number. Now how to find average mass number? You already know the existing ratio 3:1. So this mass number 35 into 75 by 100, 75 by 100 and 25 by 100. That's the ratio is 3:1. So plus 37 and its ratio is 25 by 100. That is 1 by 4. So this is 3 by 4, 1 by 4. When you solve this, you will get 35.5 U. So this is the average mass number of chlorine atom. In this case, you have to take this as mass number. And it doesn't mean this is like when you take chlorine, it is going to be the mass number. No, this means whatever chlorine you have is combination of two isotopes, this and this, which are present in the ratio 3:1. There are other elements whose isotopes are also present. Other common example is carbon. You can search for some other isotopes also, like uranium also has different isotopes. One is radioactive, one is not. So you can search it more on net, and if you have any difficulty in this part, please tell me. Thank you.